Hi, this is Lori, and welcome to my series on the Pico W. In this episode, we're going to finish our Pimon game, which is a memory game for the Pico W. If you haven't seen part 1, I'll put a link in the description, so start there because we're going to jump right back into the programming we need to get this game going. Alright, welcome back to the second episode of the Pimon game. In this episode, we're going to start off with figuring out a way to capture the input from the player. So we'll use a lot of the same code we used in the first episode. So we'll go quickly over that. Importing, setting up our buzzer. This is the function we created in the first episode to play the tone. Then this is the dictionary that we're using as a part of that function. Setting up our LEDs. Now this is the new piece here. We're setting up our buttons with pull down resistors because I have them connected to the power rail. And then we're going to use interrupt functions. And so I'll make a link to episode where I really describe interrupt functions in detail if that's something new for you, because I'm going to go kind of quickly through this. But we need a few things to do some debouncing. And then the interrupt function, when the button is pressed, all it does is pass back that, for example, we press the red button, it'll pass back that the red flag will be set to 1 rather than its default of 0. So you can see here's the interrupt function for the red button. And if we have a real button press, so this is the debouncing piece here, then it'll return a 1 back to the main program. And we'll do that for the green, blue, and yellow buttons. And then you need to set up your interrupt requests, sort of activate them. And so that's what these piece of code does here. And we call the functions that we wrote above when any of these buttons have been pressed. Then for this one, we'll just create a player sequence. So this is what the player is going to input. And we'll say they need to input at 8. So we'll just print to the screen that you need to enter 8 button presses. And then here's the really important code that listens for, I guess is a good way to say it, whether the buttons have been pressed, and appends that into the player sequence. So let's look closely here at the red. So if the red flag is 1, that means that the player has now pressed the red button. Then we'll immediately turn it back off again because they may need to press it again. And then we'll append to the player sequence list, we'll append a 1. And we'll make sure we go ahead and turn on the LED and make the sound that goes with that button. So it's going into that button dictionary that we talked about in last episode to get the correct sound out of that dictionary. And it'll play that for a quarter of a second. And then it'll turn the LED off. And it'll do that if the green button has been pressed, the blue button, or the yellow. And you can see it's inside a while loop. So as long as we've not filled up the player sequence yet, so as long as we're less than the 8 presses, it'll keep sort of listening for button presses and do the appends whenever the player has pressed the buttons. Then once that's complete, it'll print out the sequence. And we have a try and accept in case we need to cancel out. All right, so let's go ahead and run this one. So it says to enter 8 button presses. So we'll go over here and I'm going to just enter them in order. So it should be 8. And you can see I entered them in order: red, green, blue, and yellow, red, green, blue, and yellow. So it worked. So that's a nice way, I think, to get it, and it's very responsive. Just as you press it, it lights and makes the sound, so it's moving fast enough to make it seem like everything's happening simultaneously. So I think we now have a way to capture the player's input. All right, now we have the game sequence and we have a player sequence. So we're ready to compare the two and see if they match or not. So actually that ends up not being a terribly difficult programming task. Just a lot of the same setup that we've had before. And I've created just a few dummy lists here to practice and see if we can get a match. So we have the device has a list, so this is the game list, and then two-player list. So one matches, the first one is an exact match of the device, and then the second one does not match in the final spot here. Then we'll make a little function because we'll need to do this comparison quite frequently in our code. So we'll make a little function to compare two lists, and all you have to do is just ask, is list 1 equal, with the double equals there, to list 2? If it is, then you'll get a print, you'll print match, and the endgame variable will be set to false. Otherwise, that means we didn't get a match, and so we'll play a low value that'll sound like you didn't win, and we'll turn the endgame variable to true, and we return that. So that's how we know it's time to end the game, because we didn't get a match. So then game over will equal this function of device 1 versus player 1, and we'll print is the game over, and we'll get either a true or false, and we should get true from that one. And we'll just sleep a couple seconds to give us a minute to look at it, seconds to look at it, and then we'll compare the two lists that shouldn't match, and hopefully we'll see a false for that. So this is how that works. And so let's go ahead and run it. And then, yep, so you can hear the little losing sound. So our match function works. And now we have all the components we need to get this game going. All right, here's our basic Pimon game. It's hard-coded to 8 tones, 8 colors, just to kind of get it all put together. A lot of this code we've all seen before, so I'm going to go kind of quickly through it. There's a lot of prints in here, so we can see are things working the way we had intended as well. So we'll just kind of roll through all these pieces of code we put together from the building block programs. And there's all the functions we have written. Here's our dictionary. Just added in our compare list function. We're going to initialize a variable called tone number, so we'll keep track of where we are in playing the list. We'll set the maximum sequence that we're going to do, go ahead and generate that, and then here's how we're going to kind of control the flow of the game. We have a game sequence, should be no more than 8, and we're going to kind of count through the numbers, because we first want to play just 1, then we want to play 2 in the list, then 3. And so that's how this while true loop is going to go, and we're going to increment the tone number variable inside our while loop. All right, so give a little time to allow the user to get ready, and then we're going to play the first sequence. So tone number is first set to 1, so it's going to play the first part, the first position of the sequence, and now it's going to wait to hear back from the player to repeat that. So we're going to use our while listening loop that we wrote before to gather input from the player. You see, we're going to print that to the screen just so we can see. Then we're going to check to see, have they inputted the correct sequence, and we'll print that to see what happens there. And then we just need to determine if we've lost or won, or we should continue. So if the game over equals true, then we'll set the tone number to 1 more than the number of sequence, and that just makes sure the outer while loop up here ends. We quit running through that loop. So that's a little way to get the game to end, and we'll print game over, you lose. Then otherwise, if game over equals false, and the tone number is equal to the maximum of the sequence, well, then that means we've gotten to the end of the game there, and the player has actually successfully repeated all of the sequence. So again, we'll make the game end by doing the tone number trick here, and we'll print you win. Otherwise, that means they need to continue, so we'll increment the tone number by 1, and we'll print continue game. All right, so that's in the end, it is a lot of setup code, but the actual, try and accept part of the program is not particularly long. All right, so we'll go ahead and run it. And you can see this is the code. This is the thing we're supposed to match. It makes it easy. So 1 is the first, so that was red. All right, so we need to press the 2. So we need to do a 1 and a 3. 1, 3, 4. 1, 3, 4, 2. 1, 3, 4, 2, 2. Oh, I messed it up. And so you can see, game over, we lose. All right, so we've got the basic program together, but it'd be nice to have some, a little more text and so forth to introduce the game to the player, and also maybe set different skill levels. So let's go see what that would look like. So here's my final Pimon game. We'll come back and talk about what else could be done to this game, because it really is pretty rich and you could do a lot of extensions to it. So all the code is, we're pretty familiar with it now, setting up all the pieces that we need, the interrupt requests, playing the tones, playing the sequences, dictionary, all our functions we need. And now you can see we're going to just allow the user to pick what skill level they'd like to do. So just to welcome them to the game, entered the skill level that they want to play. And I kind of challenged myself to do a little more effort in terms of error checking, in terms of input from the player. So that's what this code here is just trying to do. So we'll say, okay, here's what a beginner would be. You need to match 8, intermediate is 14, advanced is 20, and expert is 31. And I added in a demo mode for showing this off, because waiting on somebody to enter 8 colors takes a while. Then I set up a variable called correct input, and it's set to false initially. And so while correct input equals false, we're going to, make sure somebody types in the right number here. And if they don't, then we'll tell them that they have to try again. So that's why it's initially set to false. So first we're going to get the choice from the user, and as most of us remember, the input function returns a string, not the numbers. So choice is actually a string, but that's okay. We'll check to see, is choice in one of the allowable strings that the person could input. If it is, then we'll go ahead and convert it, because if you try to do an int on a string that isn't a number, then you just kind of crash out of the program. So this is my way of kind of avoiding the program crashing. And then we'll say, okay, they made a correct choice. We'll turn it into an integer, and we'll set the correct input to true. We'll tell the user, okay, you need to match this many colors to win. Give them a couple seconds before the game starts on them. And otherwise, then they didn't enter a valid choice, and we'll give them a chance to try again. All right, so that's how that works. So that ended up not being as difficult as I thought. At first, I thought that was going to be a lot of work, but it ended up being not too bad. So it was a good challenge for myself. And then we're going to go through the code that we already used to run the game, and everything is pretty much the same. All right, so we'll run this one last time. And I'll come down here and run it in demo mode. And we need to match the 4 colors. You can see why it's nice to have a couple of seconds before you get started. Yeah, and I won. All right. Wow, was a lot of fun putting this together. It did take me a little while to work on it. That's why it's been a little while since I put some episodes out. But it was a lot of fun, and I definitely learned a few things with MicroPython that I didn't know before in putting together this game. We're going to wrap up by discussing what else could be done to this game, because I hope that some people take it and maybe go further with it. Here are a few of the additions I think could be made to this game to make it even cooler and funner to play. I thought about adding a display so that we could separate the game from the computer, and that all the interaction with the user could take place using some kind of a display. Maybe even the simple SSD 1306 would work. And you could use buttons or a rotary encoder to get the desired skill level from the user. So that would be a nice add to this game. There's definitely room on the breadboard to add a small display, so I think it could be done. Another thing we could do is add some different variations to the game. For example, you could make a really, really long sequence, generate a really long random sequence, maybe 500, 1,000 long, and then see how far the user can get rather than just repeating a certain number. They see how far they get and report back, okay, you did 50 tones correctly. So that would be another variation on the game, and then people could compete against each other maybe. That would be fun. The other thing is you could make the prompt sequence go faster and faster as it gets longer and longer, and that could make the game harder to do. So you could maybe make some more skill levels by increasing the speed of the playing back of the sequence. I think it would be fun to add some intro song, a winner song, and a loser song instead of just the bzzz for losing. It'd be nice to have a little sound for the winning. So that would be something you could add to the game. You could also add more buttons and colors. I have seen other games where there's like 6 different colors, so that's a possibility too. Definitely make it harder to repeat. And then of course it'd be pretty fun to mount it all onto a proto board and design and print a cool enclosure for it, so that you have a handheld game that you could take anywhere. Well, those are some of my ideas. I'd love to hear whether you're going to try to do this game and whether you're going to try to add some of these next steps, or maybe you have some other ideas of how to take this game another step. Well, that's it for this episode. Thanks for watching.